One of the symmetry operations is reflection. Reflection is another type, which is defined by its axis or line of symmetry, that is a mirror line, which is called the mirror line. And that mirror line makes a reflection of our original point to another point. For example, each point P is mapped onto a new point, which is P prime, which is called the mirror image of it, of the line P in the mirror line, such that this line P prime is perpendicular to the mirror and such that their distances are preserved. Reflection is a symmetry operation that preserves distance. Another key point here is that all points on the axis are invariant. If there is a point on the mirror itself, that point will remain invariant, means it is not going to be changed by the symmetry operation, which is called reflection. Look, this one, this is an example of reflection, where this axis that you see is acting as a mirror. Whenever we are reflecting from this to the other side, this axis is acting as a mirror. And when we are reflecting it from here down, like this one, the x-axis is acting as the mirror. Look again this point. This is the original point, which is A. This is the original point, and then this is the image. This A prime is called the image of the original point A. So the point 2, 5, it is final destination after reflection. We have got a new point, A prime, which is 5, 2. So our purpose in this case is, given the first point, that is 2, 5, then how can we calculate and arrive at the new point, that it would be 5, 2. How do we get the new point? So that is the purpose of this topic. For example, if the original point is A of x, y, then our new point is going to be x prime, A prime of x prime, y prime. So these are required, but these are given. So that is the way we are going to deal with the problem. Here are some formulations. For example, if we have x-axis and y-axis, this is our line. This line L is a line which is acting as a mirror line. And with the help of this mirror line, I have one point that is the object A of x, y, that is my object point, and this is my image. The image is A prime of x prime, y prime, and this line is at radius r. And after reflections about this line, this is a new point which is A prime of x prime, y prime. So our target is, given these two, how do we calculate these 2 points, x prime and y prime? And here are the formulations. The slope of such line, m, is always given by tangent of the angle, because this red line that you see is at an angle theta. This is at an angle alpha. And because angle of reflection and the angle of this original angle, that is this angle between the red and this blue color, is theta minus alpha, the same has to be after being reflected, because the angle of reflection and the angle at which the image is created has to be the same. Both are theta minus alpha. So altogether, this whole angle is alpha plus theta minus alpha plus theta minus alpha, which will finally become 2 theta minus alpha. So having this in mind, I want to decompose this one into y, and this up to here as x. And the same is true for this one. This will be y prime, and up to there it will be x prime. And that is the way we relate those coordinate systems into its components. So according to this, the angle that you observe here, x is r cosine alpha and y is r sine alpha. And as I told you, the final image here is at an angle of 2 theta minus alpha. So when we decompose that into its component, x prime is r cosine of 2 theta minus alpha, and y prime is r sine of 2 theta minus alpha. And then with the help of sum and the differences of cosine and sine identities, we can rewrite x prime as r into cosine of 2 theta cosine alpha plus sine of 2 theta times sine alpha. And grouping together similar terms, this is already what is here, and that is in turn x. So that would be x times cosine of 2 theta for this part, and for r times this side, that would be r sine alpha, that is already y. Then we replace it by y. So x prime is simply x into cosine of 2 theta plus y sine of 2 theta. With similar argument for y prime, r sine of 2 theta minus alpha is expanded in this way, and substituting the values for x and y, we can finally write y prime as x sine of 2 theta minus y cosine of 2 theta. So if you are not sure on how to make trigonometric expansions like sine of theta plus alpha, and also for cosine, here is an identity for you. Have a look at it, and this is what we have used in the derivations. Reflections may happen through an axis which passes through the origin, in which case the equation of our mirror line is written in the form of y is equal to mx, or next we are going to see the case where this line will have a y-intercept. Y is mx plus b form. We will talk about that next, but let us get started with this simpler case in which our line, which is the mirror line itself, is passing through the origin. By then, we directly use the formula that we have derived a while ago, which is simply x prime is x cosine of 2 theta plus y sine of 2 theta, and y prime is x sine 2 theta minus y cosine theta. And this is something we have obtained from the derivations that we have made a few minutes ago. So if we wanted to write it in a matrix form, we can write this in this way. They are identical, and you can multiply this one by, you multiply cos 2 theta by x and sine 2 theta by y, and sine 2 theta by x minus cosine 2 theta by y, and then you will simply get this one. They are same. For a mirror line which passes through the origin, if this is given, this is going to be the required. And here are some trigonometric identities that will help us to relate, because if an angle is given, whenever this kind of line is given to us, y is equal to mx, this is the slope. This m is taken as it is slope, so that slope is m is equal to tangent of theta. And with the help of these trigonometric identities, we can get cosine of theta, and because cosine of theta is not appearing in our formula, but rather cosine of twice theta, so we have to have a way to convert this cosine of a single theta into cosine of twice theta, and that is the way we have to convert our angles in such a way that finally we can plug into our formula not cosine of a single theta, but twice of it. The same applies for sine, and we have to use the formula that you see here. After doing so, if we want to find equation of the line, slope of a line that passes through 2 points, p1 of x1, y1, and p2 of x2, y2, if that is given, then the slope is m is equal to y2 minus y1 over x2 minus x1. That is the formula for calculating slope. The point slope equation of a line that passes through any point p1, x1, y1, and with the slope m is given by y minus y1 is equal to m into x minus x1. This is a well-known slope formula. Another one is the slope intercept equation of a line with slope m, and the y-intercept b is y is equal to mx plus b, and this one is the y-intercept and this one is the slope. This is equation of a line having slope and y-intercept. And equation of a circle with center hk, if this is center of the circle, and radius r is given by this formula. This is equation of a circle. The formulas that I gave you here are to guide you whenever you wanted to reflect from one point to the other, and on the way, if you wanted to calculate the corresponding equation of line or the corresponding equation of a circle, this is a quick reminder of